Okay. All right, everybody. My name's Adam Breece. I'm a software engineer here at FlowPlay. Maybe you've heard of us. And today I want to talk about some of the more process-related problems that we've come across and solved that tended to come up or pop up more as a function of the size of our team and the number of people we had working on HAXE. Stuff that maybe doesn't apply to a 2 or 3 person team, but when you start getting 10 or 20 people in the room, it starts to matter. Some of the things I'm talking about are sort of OpenFL specific, so depending on whether or not you're using it, they may or may not be as relevant to you, but hopefully there's some broader lessons we can all take from this. Okay, so to explain what the heck this is all about, we're going to start with a true story from FlowPlay lore. The names have been changed to protect the guilty and innocent, but so one day the CI server tells us that the build is broken. Not an uncommon thing. The dev who checked in the breaking change tells us the build is not broken. Also not an uncommon thing. However, 3 more devs tell us the build is not broken. All right, maybe someone screwed up the CI server. That has happened before. But then a few more devs tell us, no, it actually is broken. And then 2 more CI servers chime in and say, no, it's fine. All right, well, what the heck's going on? So we all scratch our heads for about 2 hours. And then a brilliant developer asks, what compiler version is everybody running? And then we all collectively facepalm and realize that the problem is that there was some code checked in that was acceptable to an old version of the compiler and is not acceptable to a new version of the compiler. That's an unfortunate waste of time that we all could have avoided. This is sort of an example of the broader type of problem we have, which is that for a while, a lot of stuff relied on word of mouth. It's tribal knowledge. And that actually worked for a while. When we first started using HAXE, it was just a handful of people sort of doing some prototype stuff. And so when we said, hey, let's take a new compiler drop, everyone was at the table and everybody did it then and it was fine. But then as more people moved over from ActionScript to HAXE, suddenly that didn't work as well and stuff got dropped on the floor. And we were actually fortunate that this was a build time failure, not something that was cropping up in runtime, where maybe the binaries we released or the JavaScript or whatever that we released, maybe they were built on a machine that used a new version of the compiler that fixed a bug, and maybe they were built on an old version. That would have been a nightmare to debug. So anyways, what did we look at to fix this problem? First, we could just be extra sure to tell everyone to install the right version of the compiler and be extra careful. But someone has to remember to do this, and what if someone's out on vacation or is sick or who knows what else? This is kind of just doing more of the tribal knowledge thing that wasn't working before. So maybe we send a strongly worded email to remind everyone. And I know everyone in this room reads every single email they get, but not everyone does. Also, there's just this human element of, oh, I see this email telling me to do that. I will be sure to do that. Oh, wait, but I need coffee first, and then I completely forget about it. Multiple emails might solve this problem, but then someone has to remember to send the multiple emails, which is, again, there's a human element that can break down here. Also, it doesn't solve the problem of new employees who may show up and go, oh, I'm just going to grab whatever the latest release of HAXE is, because that probably works, but what if we haven't moved forward? Or what if they have an old version on a machine they're using at home or something like that? So perhaps we could put it in a wiki, which does take someone to maintain, but okay, it's kind of always there, solves the new employee problem. But as someone who updates the wiki, it's very easy to forget to update the wiki. Sometimes I do that much later than I should. And again, not everyone reads it. This also doesn't solve the problem with keeping the CI machines up to date, right? Someone has to remember to do that. This guy has to remember to do that. And I can tell you it doesn't always happen. So the ultimate solution is don't rely on the dumb human. And I get to say that because I'm the dumb human who didn't update the CI machines, which is one of the reasons we had this whole compiler kerfuffle. So how do we do that? With the compiler stuff, we actually just check the compiler version at build time. This is a snippet of code out of our OpenFL project.hxp. It checks, hey, this is the version we're expecting. If we don't find it, then we complain to the developer, and they know exactly what to do. You can also do this with a project.xml. It's a little bit hackier, but if you're not using the project.hxp format, there you go. There's probably some clever way to do this with a raw HXML or macros or something like that. We haven't looked into that because the OpenFL solutions work for us. But the nice thing is that this blows up the CI machines if someone forgets it as well. It's basically a universal solution. No one has to think about what compiler version they're using, except for whoever decides to change the project config. Haxelibs present a similar versioning problem for us. This is the worst thing you could possibly do when declaring your haxelib dependencies. Please don't do it. If you take nothing else away from here, don't do this. Don't have just completely unversioned haxelib dependencies declared in your project. It's just a disaster waiting to happen. Ultimately, if you think about it, you're depending on the global state of your machine to determine which haxelibs you're using, and we all know the global variables are bad. So that ought to be enough to convince you. Even if you were convinced you could be okay with this, there's still, with larger teams, everyone has to know, oh, I need to go update to a very specific version of haxelib and make sure that I'm set there. That they usually find out they have to do that because their build is breaking, and then there's a whole bunch of confusion around that. It's also very possible if someone doesn't do that update properly that they spend a week writing a feature coding against an API that's been broken, not knowing that we've moved forward to something new. And again, missing this on the CI machine is really bad. We could be shipping with stuff that we thought was fixed because the dumb human forgot to go configure the CI machine properly. Fortunately, there's a really easy fix. You don't have to do any fancy project.hxp stuff or anything like that. You can just declare a version in your project files like this or your HXML. That's great. Everybody should be doing this. And this is actually what we did for quite a while at FlipLabs. We just had it this way. But there's still some problems with haxelibs that bother us. The first one is that whenever we make a haxelib change, if you're relying on a global repository, everybody has to go run haxelib. And if we've changed 3 or 4 different things and everybody needs to go update, and it gets to be a real mess that way. Inevitably, people run into problems. This manual stuff is expensive, and if I, as a dev, have a problem running an update, like say, for whatever reason I can't get to the haxelib servers, well, I'm blocked from getting work done until that's taken care of. The CI servers are once again a problem. That we have 10 or so. That's a much larger amount of time or much larger cost to at least my day to go set that stuff up. We could add some auto updating as part of the build, and we did do that on a project a while back. The problem is, well, then the builds might fail in the middle of the night because there's a network issue. We don't want that. We don't want QA to not be able to test stuff the next day because there was a network issue. It's just an external dependency. That's another point of failure we don't want to deal with. And it ultimately just ended up being a hassle in practice. We also can't take hotfixes easily this way. Sometimes, in fact quite often, there's a production issue and we can't wait on a fix. We're not waiting on the next official release of something to come out. And it's real ugly if you want to tell all of your devs, hey, here's this patch you should apply to your local HAXE repository. We're not sure where it is on your machine because you may have installed it in different spots. And by the way, we really hope we don't forget that it's there. It gets really messy. The one solution would be to point people at a Git repository, but at the same time, Git comes with its own issues where it's still an external dependency that we want to try to avoid. And getting everyone to sync to exactly the right commit and branch might be a little tricky. And Git can get into weird states where the only solution is, all right, well, let's just go blow away the whole directory. That's a huge drain on, and redo the clone. That's a huge drain on productivity. We don't like it. And more importantly, for some of the haxelibs we use, as releases, they have precompiled binaries in them for their native targets, iOS and Android primarily. Those aren't always in the Git release versions. So now anyone who's doing mobile development also has to know how to go and rebuild these dependencies, and that's even more time before they can start working. Similarly, for the CI machines, someone has to go in and run all of those commands and hope they don't screw it up. On top of that, there's a best practice of you want everybody using the exact same binaries for your dependencies that you can, and you want to know exactly the binaries that you're shipping. And if we have to rebuild every native library on every single CI machine and every single dev's machine, there's a chance that things are different there. It's much better if, well, we know exactly the bits that this dependency was compiled with. So, the solution. Check all the dang things into source control. There's a lot of opinions out there on the internet about whether or not you should do this. I don't know that there's a definitive answer, much like the tabs versus spaces debate, but it works out really well for us. So the first thing is that nobody has to know anything new or do anything extra to handle this. You run your git pull or svn update or whatever it is, you're using for version control, and boom, you have your dependencies. Great. In practice, nobody notices when we make a Haxelib change. We add stuff, I update stuff, we do whatever. Unless that new library breaks something that this person is working on, which does happen, they don't know that anything has taken place. It also solves the fresh checkout problem. It gets us really close to the ideal scenario of, well, we do a fresh checkout of the project and we can build it. Developers do have to have, of course, the compiler installed, and because we use OpenFL and Lime, the global versions of OpenFL and Lime need to be installed so that they have access to those global commands. But that's it. There's also no extra tooling for managing this. In a previous life, I worked at Microsoft on one of the dev tools teams, and we had tens of people dedicated to tooling built around just managing dependencies that people need to get their job done. When you have several thousand developers, maybe that's justifiable, but it can become a huge time sink, and for someone at our scale, it just doesn't make sense. On top of that, hotfixes are really easy to patch in. You copy the files in, and you check them in, and boom, they're there. On top of that, in addition, just having your dependencies in version control makes some things better. We get rid of the network-based build break problem, and we also have some good business continuity stuff there. Like, we always have the sources for everything we've ever released. And if the Haxelib server bursts into flames tomorrow, we're not really screwed. It's okay, we have the copies of all of the stuff, and it's in all of our backups, and whatever, everything's great. And it also makes some troubleshooting stuff of some things easier. You can go back and use your native diff tools that you're used to see, well, what's changed? We have this, a couple months ago we had some weird memory issue going on with iOS. Well, what the heck has changed? We know that we had some churn in some of the dependencies we used. Is something going on in there? It was much easier for me to just do an SVN up to the specific points in time where I knew things were changing so that I can then change it instead of having to fiddle with Haxelib to try and get to exactly the right sources we were using, and so on and so forth. That was very good. Okay, so the way we accomplish this is using the Haxelib local repository feature. I don't know how many people have heard of that before or ever used it. All right, we have a few hands. You can just run haxelib new repo in your project directory. It creates this little .haxelib folder, and any haxelib commands or hax commands run from within that project directory will reference this haxelib repository instead of your global one. There is a big caveat, which is if any haxelib or hax commands run from outside of this directory, will not reference it. So you have to be careful, and we're going to talk about that a little bit more. But it makes it really easy to keep everything in one place. And for the most part, the tools kind of just work. We'll talk about that some more. So, like I mentioned, the local repo is only used if you're running your commands from directly inside that directory. More frustratingly, not all haxelibs and some of their associated tools know about the local repo and will use it properly. Sometimes they'll try and call out to global dependencies and that sort of stuff, or if they're, for whatever reason, running a shell command that isn't running in that exact directory, then things will break. I think there's a fix in the works for the subdirectory problem here, so you can run haxelib from any subdirectory of your project and it'll know about the local repo, but I don't know the status of that right now. Fortunately, Lime and OpenFL are local repo aware, so you can even, the Lime and OpenFL build tools you just run Lime from the command line, that's going to be in your, because the way the paths are set up, that's going to be using your global version of Lime. However, it knows to check for a local repo and go, oh, you don't actually want me, you want the thing in your local repository. I'll just pass your arguments to that, and we're off to the races. So that works really well for us. That feature's been in Lime since like summer 2017, I think. So anything since version 5.3, you should be good there. I don't think any of our devs have updated their global Lime or OpenFL installs since we started doing this. So that's a testament to the fact that it works. Oh yes, here's a workaround for any haxelibs that don't obey your local library appear, in my experience anyways, to obey this environment variable where you can tell haxelib, no, this is where I want you to, this is the repository I want you to use. And you just point it at the local repository, wherever it is. And that's just setting an environment variable in the project.xml. I assume there's other ways you can do that depending on how you're running your builds. One thing that bothers people is that you end up with duplicate copies of haxelibs if you have multiple repositories or multiple projects in a repository, or even just multiple checkouts on your machine, that sort of thing. disk space is cheap, is my opinion. But if you really want to, you can use a shared, you can set this up as a shared thing using either that environment variable or the OpenFL project actually allows you to say, no, hey, this is the haxelib I want you to use. You end up running into the same problem of any commands you even run from your project directory, like haxelib list or something, aren't going to reference that. You're kind of getting a weird state there, but if you really, really care about not having duplicate stuff in your version control, you could do this. We don't do this, we don't need to. The way things work for us today is just fine. We also, because of this, binaries get checked into source control, which and one of the reasons we're fortunate we use SVN is that it handles binaries better than something like Git, where Git's going to keep your entire history, and so if you're frequently changing binaries, then that can really bloat the size of your repository. Git LFS is sort of a solution, although anybody who's worked with it doesn't. Nobody I know who's worked with it considers it a great solution for the problem. So that's something you should consider if you're really relying on Git and considering to do this. But if your binaries don't churn that often, then maybe it's not such a big concern. And finally, someone still has to manage all this, which means we're not entirely free of the dumb human. Making sure that hotfixes are part of the next or official release of a haxelib, for example. Like, okay, we've hacked in it's very tempting for devs to go hack in a little change to Lime or OpenFL or whatever else we're using because, hey, get something fixed today. But if we don't know about that and make sure that that fix gets merged in to the real release, when we rev to a new release 6 months down the road, we may actually lose the fix and we end up being confused. I have some scripts to help this, but it's still not entirely problem-free. The upside is that only one person has to worry about all this instead of the entire team having to worry about managing all of this stuff on their machines. There's a related problem to these haxelibs, and that's that some of them use external tools. And those external tools, sometimes they assume there's going to be a global version of this tool installed. Node.js is a good example for us. We use Philippe's modular haxelib to do our JavaScript splitting, and it relies on Node.js, and it doesn't ship with its own copy of Node.js. So we either have all of our devs go install hopefully the right version of Node and hopefully the right packages and everything and hope that everything works, or we check all of that into SVN as well. We're fortunate that with the modular haxelib, at least, we can override and tell it, no, this is the version of Node I want you to use. This is the path to Node I want you to use. So we can just point it right into our project. It feels kind of hacky, but I think it's been in use for about 2 years here now, maybe, year and a half, and we don't have any problems with it. Now, the downside, once again, the binaries and source control, you still have that problem here. Not such a big deal in SVN or Perforce, but in something like Git, it's a bigger issue. We haven't run into this yet, but like for us, but some tools may assume a global version and you may not be able to override that. When that happens, to us, it's going to be a real pain. We'll probably have to go make some changes to them somehow. Hopefully get those merged upstream. If not, that'll be even worse. But so far, so good. But it is something it is a potential flaw in this plan. Okay, so one last bit is about the HAXE Completion server, or the code completion, the compiler server. I've heard it called a bunch of different things. For anyone who's not familiar with it, you can run the HAXE compiler in sort of a server mode, where it sits in the background and provides not only code completion services to like your IDE, like Visual Studio Code, but it also acts as a compiler cache. And why do we care about this? Why is this the problem? Well, we care about it because it's a huge improvement to our build times. Like our HTML5 target, which is what a lot of people are building, is 30% faster if you're using the completion server. That's a big deal. You run it by telling HAXE compiler to wait and give it a port, and then you tell either your HAXE build command or your OpenFL build command to connect to the completion server, and you're off and running. Everything's happy. So why is this a problem for us? Well, the difficult part is getting people to know about it and use it. We tried the strongly worded email approach and the wiki approach, not so great. So the solution is we enable it by default in our projects. We just say, well, yeah, in our project.hxp, just, yep, HAXE, you're going to connect to this thing. The dev doesn't have to add anything on the command line, it's just going to happen. And you can do the same thing in your XML or your HXML. And then, of course, when the dev runs it, this happens. Because they don't know anything about the completion server. Oh, dang. The solution is really, really dumb, or rather really simple. Every time we build, we also print to the console saying, hey, we're going to try and use this thing. You should make sure you run this. And you can echo with the project.hxp or the project.xml. There's probably some way to do it with the raw HAXE HXML. But this seems to have eliminated all the confusion around that, or almost all of it. But there are still some downsides. First and foremost, as I'm sure most of you are guessing, it's annoying. You have to remember to start the completion server. That's probably the biggest pain in the butt. But you really only have to do it on reboot, and as long as it's running, it's there. And I just have mine set in a startup script, and I'm good to go. People did complain for a few days, but that's mostly died down. It might just be because they're sick of complaining about it and me not listening to them, but it seems to, in practice, have been a good thing. More technical issues are that you could run into port conflicts. This thing's listening on a port on your machine. What if something else is using it? Like Visual Studio Code has its own version of the completion server running in the background. We have an option where you can specify a define on the command line or an environment variable and just say, no, I want you to use, instead of whatever's hard-coded into the project, use this value instead. This is the server I want you to listen on. That's a fairly straightforward fix and solves my problems at the very least, and I haven't heard anyone else complain about it. Oops, there's the full thing. The CI environment's another problem. I really don't want to have to worry about keeping a completion server running on a CI machine, especially if it reboots after an OS update or something like that. There's also the concern where multiple jobs can be running on a machine. And if we try and spin up a completion server, we have to then track which port is in use where, and there's all sorts of state management and everything else that's ugly. So the solution is we just turn it off on a CI machine. We check an environment variable. If this environment variable isn't set, then we'll enable it. Otherwise, we will not use the connect feature. And that's also a way for devs who really, really, really hate the feature to turn it off, but they have to opt out. And as we hopefully all know, people tend to just stick with the defaults, whatever they are. And so far, it's been pretty good. But it's mostly a thing on the CI machines. So the dumb human doesn't have to intervene all the time. Okay, there we go. That's everything I had. Any questions? All righty. Oh. So the question is, have we thought about bypassing haxelib and just using class paths? Yeah, we end up with the same thing of having checked in those files, or the source code still ends up getting checked in. You do avoid the haxelib repo file. It's a little maybe less obvious what you end up using for your dependencies, and at least when I'm working on getting us to either use a new haxelib or actually moving to a new version, it's nice to be able to use the haxelib command to swap between versions of haxelibs. So there's a small benefit there, but there's no reason that wouldn't work. It's almost maybe a better solution for you even. What's the name of the tool? Lix? I have no idea what Lix is. The question is, could Lix have solved this problem? Quite possibly. Yeah, we should talk. The one downside there as well, we maybe have to have other people install, maybe have to have all of our devs install another tool, which is something we want to avoid. But anything else? Mm-hmm. Yeah, so for people on the stream, the comment is that it would be nice if that, like Gradle, which starts its own daemon in the background automatically, if the HAXE compiler could start its own and manage its own server in the background for improved compilation speeds. And yeah, that would be nice. There may even be some way we could hack it into the project file to have it manage that, but it starts to grow the scope of what that thing does, and I'm not super in love with it. But it sure would be nice if the compiler just handled that for us. Anything else? Excellent. Thanks, guys.